Welcome to Math Simplified by HM. Heartily welcome everyone to today's exploration of right angle triangles. We are stepping through the formal geometric proof of dropping an altitude to the hypotenuse, a truly fascinating property you need to know. Please take a moment to like, share this with your well-wishers and subscribe to the channel for more. Don't forget to click the bell icon. Got your notebook ready? Remember, you can pause at any time. Let us get started. Let us start by stating the theorem clearly. If an altitude is drawn to the hypotenuse of a right angle triangle, the two triangles formed are similar to the original triangle and to each other. That means in a right angle triangle, if an altitude is drawn to the hypotenuse, then the two new smaller triangles formed are similar to the original large triangle and they are also similar to each other. To prove this, we need to set up our parameters. We are given that in triangle ABC, angle B, that is angle ABC is 90 degree. Segment BD is perpendicular to segment EC, that is segment BD is perpendicular to hypotenuse AC. And point D is such that A, D, C are collinear. We have to prove that triangle ADB is similar to triangle ABC and triangle BDC is similar to triangle ABC, and also we have to prove that triangle ADB is similar to BDC. Now let us look at the first step, comparing the smaller left angle triangle ADB to the original triangle ABC. Triangle ADB and triangle ABC. In this triangle ADB and triangle ABC, we have angle DAB is equal to angle BAC, common angle in both these two triangles, and angle ADB is congruent to angle ABC, each is 90 degree. Therefore, triangle ADB is similar to triangle ABC by a similarity test. The bottom triangle now here, original triangle ABC and bottom triangle BDC. Now in triangle BDC and triangle ABC, angle BCD is congruent to angle ACB. Angle BCD is congruent to angle ACB, common angle, and angle BDC is congruent to angle ABC, each 90 degree. Therefore, triangle BDC is similar to triangle ABC by a similarity test. Name this as a second similarity. Now we have from one, triangle ADB is similar to triangle ABC, and from 2 we have triangle BDC is similar to triangle ABC. So see in diagram, triangle ADB is similar to triangle ABC, triangle BDC is similar to triangle ABC. Logical deduction, since both small triangles are similar to the large one, they are similar to each other. Therefore, triangle ADB is similar to triangle BDC. This is the third similarity. Now from first, second and third similarity, we get triangle ADB is similar to triangle BDC is similar to triangle ABC. Thanks all. That's it. Don't stop practicing and never stop exploring the beautiful world of geometry. Please like and share this video with your well-wishers, subscribe to the channel and click the bell icon to stay updated with us. Enjoy the great time and thanks for watching.